today we are going to spend half an hour together, probably like 25 minutes on the presentation, and then we'll have 5 minutes available for questions if I match the timing I intend to. As discussed before, we'll be speaking about infrastructure, edge, and connectivity, and basically what it takes to build and operate a global serverless provider, which is what we are doing at Koyeb. So let's get started. Basically, I am Yann. I spent the last 12 years building cloud service providers. I built first in 2011 a company. I was part of a company called Outscale, building AWS-like services in France. In 2013, I started building Scaleway. And since 2021, I'm building a company called Koyeb, where we are basically providing a serverless platform. And basically, if you look in the future at this pace, I will probably still be building cloud service provider in 2030. So we'll dive into the subject. So let's get started by exploring what is actually Koyeb doing. What we are doing is we basically allow developers to deploy full stack application in minutes. And what we mean by that is that we simplify application deployment. So we are building a platform where the aim is basically to let every developer deploy application without having to learn any specific skill sets in terms of cloud provider. So you don't need to learn something new compared to what you already know. You can easily deploy with containers or native code. And we will take care of the continuous deployment part. We abstract infrastructure management so that you don't have to deal with that. We basically also take care of resiliency and scalability. And we also work on improving performance by simplifying global deployments. We'll dive into this later. And lastly, we make sure that you basically have sustainable engineering and cloud infrastructure costs, which is a key topic if you look at your usual cloud infrastructure builds. Maybe who in the audience right now has a software engineering background? Okay. Do some people in the audience have a platform engineering background or SRE background? Fewer. So, all right. Let's continue. So basically, the platform, what we let you do is we let you deploy web applications, APIs, microservices, background workers, and also manage databases. And this can be anything. We're really agnostic in terms of technology you are deploying. So you can deploy from a simple Docker file or also with a GitHub repository which we will build for you. If you look at what it looks like concretely, we basically build the application for you, we run it, and we scale it for you. This is how it looks as a user. So if you use our CLI, we also provide APIs and other automation tools like Terraform and Pulumi. But if you use our CLI, it's 3 commands to deploy an application. So you just install Koyeb, you init the application, which is going to deploy it. You select your regions. In this case, it's deploying in Frankfurt and Washington. And then your application is going to be live and with basically a domain which is automatically set up and the traffic which is automatically routed to your application. Now let's dive into the subject. So if you look at the title of the talk, you have 2 keywords in this talk, which are global and serverless. And I want to dive into why it matters before explaining how it works exactly and how we built the platform. So the subject of deploying globally is, in essence, what we're basically fighting against is that data only moves at the speed of light. So it's just like, it's a fact. The reason why it matters to deploy in multiple locations is because your latency is going to be bound by this fact and by the capacity of network infrastructure to process your data. And what we're trying to improve when we deploy in multiple locations is basically the performance. And the key challenge we are usually facing is there are two key challenges. One is regulation, and the second one is data locality. So if you look at GDPR, for instance, it requires you to process data in specific locations depending on your agreements. And data locality is a question of where are your databases located. But the thing is, like, anyway, if you want to deploy across multiple locations, it's going to be tricky because you need to synchronize your deployment across all of the locations where you want your code to be running. You need to take care of networking, so you need to be able to provide a global networking layer and also take care of security. And you need to take care of this key subject of data locality. And so the other key topic is serverless. And I want to clarify one misconception. When we speak about serverless, we are not necessarily speaking about functions. Because serverless has been popularized as a word by AWS with Lambda, but it's actually way more than this. Today, serverless is used for containers, function, and databases too. And it doesn't require a full rewrite of applications. And it's not an invention of us, it's just like the way the industry has evolved in the last 5 years. Serverless can apply to any kind of deployment. And we believe it's a key thing because our fundamental belief is that serverless will supersede previous infrastructure technologies. So if you look at the last 20 years, there has been a shift. From 20 years ago, people were deploying on-premise, and every 5 years approximately, there has been a change in how applications were deployed. So we moved to virtual machines, and AWS came with EC2, which became IIS, and then Kubernetes came. And what we're saying is that basically the next abstraction layer is serverless. And we are not the only one saying this, because if you look at what the Cloud Native Computing Foundation says itself, they are saying that Kubernetes is going under the hood, and that it's going to become like Linux, that it's probably going to disappear in favor of higher level of abstraction. And that's what we are basically building. Now let's dive into actually how it works and how we build it. So this is what is abstracted by our platform. What we are providing is an abstraction to all of these functionalities. So we abstract cloud service providers. We pick different players and mix them up to provide the best experience. We abstract orchestration so that you don't have to mess with Kubernetes or another orchestration engine. We also take care of building the app, so we take care of continuous deployments. We provide monitoring as part of the platform. We deploy globally. We take care of storage, and we also provide a networking layer, which is a service mesh. So I'd say if you are not familiar with service mesh, it's higher level. By the way, are you familiar with what is a service mesh? Who knows what is a service mesh? Huh, interesting. So basically, service mesh dive a bit into it, but it's a higher level private network. So it makes it simple for your apps to talk together. And I have a slide on what is a service mesh. Basically, it removes the need of having virtual private networks because it provides an easier community to use for developers. Now, so let's look at exactly how this works. When we built the platform, we had like 4 key requirements. The first one was to have fast builds and execution. So basically, we want to have something where people don't constantly wait on the platform. A common problem you have with cloud service provider is that they are sometimes slower than on your own laptop, which is kind of a pain. We want people to be able to easily deploy globally. We need, as a cloud service provider, to take care of multi-tenancy and security. And lastly, we need to be able to easily scale the platform to support tens of thousands of applications. So to match these requirements, we had to choose the right technology. We have 4 key abstraction layers we could have built on top of. The first one is cloud provider primitives. So basically building on top of, let's say, Lambda or something like this on AWS. This is actually something which a lot of higher level providers do. If you look at, for instance, Versal or Netlify, it's built on top of other cloud service providers. The second possible abstraction layer is Kubernetes, which is also a common choice. The third option is purpose-built software. And the first solution is racking our own servers to provide even different kind of experience. We went with purpose-built software. We decided to not build on top of cloud provider primitives because we would be capped at their own capacity and own feature sets, because basically when they build their own products, they tend to take a decision to go into where they want. We started actually by building on top of Kubernetes, but we hit some limitation about multi-region and actually also including the virtualization technology we wanted. And so we ended up building our own software and engine to provide this experience we wanted. And the first option, racking our infrastructure, is something we might need to do at some point. But basically, we don't need to do it because there are enough options right now in the market. So it would take a lot of time in a global setup. So we're skipping this for now, and as long as we can. So basically, if you look at stacks, this is what it looks like. So we're deploying containers inside of Firecracker micro VMs on top of normal servers. If you look at the left of the slide, you see what we use on the orchestration side. So we rely on HashiCorp Nomad. We use Firecracker as a virtualization engine. We deploy all of this on top of our servers, which are provided by cloud service providers. OVH, Scaleway, or IBM provides very good and high performance. And for the networking layer, we actually rely on Puma, which is doing the orchestration of our network, and Envoy, which is actually doing the traffic routing. So if you look at the stack, this is a simplified version. So on the left, we have the control plane, which is basically our own software, which is transmitting orders to Nomad for the orchestration. And on the right, you have the data plane, which is where customer workloads are running. So we run containers inside of micro VMs, which are running on top of hypervisors on top of our servers. And so, yeah, we're relying on CoreOS for the hypervisor, and that's the story here. If you look at more deeply on why we picked the solutions, Nomad is our workload orchestration engine. The reason we picked it was because it's easily extendable, it's simple to use, and it actually provides multi-region capabilities out of the box. And it has a pretty small footprint, and it's easily scalable. And this is in comparison to mostly Kubernetes, which was the solution we had before, which is really hard to extend if you don't want to fight with a global community, which is controlled by the CNCF. The second key technology is Firecracker. So if you're not familiar with virtualization, it's actually virtualization engine. So it's a lightweight virtual machine monitor, and it relies on kernel primitives, which is Linux KVM to manage micro VMs. It was built by AWS originally and open source by AWS. And the key reason why they built it is to provide fast boot for auto scaling. So it's not doing orchestration at all, and it helps secure and isolate container workloads, basically. The third key technology is Kuma, which is actually providing all the networking layer. So it's dealing with all the security between the services. So it makes it so that when you have two different services which are talking together on our platform, it's going to be fully encrypted. It provides automatic DNS provisioning and native layer 7 load balancing. And it's completely transparent to developers, which makes it so that if you deploy two services across two regions of the world, you can just make a simple HTTP request, and it's going to be fully encrypted. You have nothing to deal with. So that's basically how it looks in terms of connectivity when you look at our platform. So for each micro VM, you have a sidecar, which is an envoy proxy, which is actually going to encrypt the traffic when you are talking to another service. And that's actually the essence of service mesh. That's actually what it brings. And from there, you can add features on top. So you can add, for instance, policies on your traffic or retries. And that's what a service mesh brings. So we have 6 core locations. We just recently announced 4 of them in preview, and we have 250 edge locations. And basically, so I'm briefly going to show you how this works in terms of connectivity and what happens when you reach a service which is hosted on our platform. There is a key point here. When you look at deploying in multiple locations to improve performance, you can deploy anywhere or everywhere. It solves 2 different set of problems. The common thing is to deploy anywhere, so you can deploy in any location individually. That's what actually AWS is providing. For instance, you can decide to deploy in Ireland or in the US or in Asia. But they are not going to solve the global layer and how the traffic is routed to all of your locations simultaneously. And the other classical solution is to deploy everywhere. So in this case, it's going to deploy in all locations simultaneously. So several serverless players are doing this, but then you lose control on the compliance part. So if you need to specifically deploy in one single region for compliance or only in the EU, you will not have control over this. And it can actually also be damaging for performance depending on where your database is located. So we provide the capacity to do both. And this is basically how it looks like. So I'm going to briefly show you how we can deploy a service across 6 locations and 3 continents. So here, what you are supposed to see is basically our control panel. You can select an example app. In this case, we'll click on Go, and we'll deploy a Golang example app. And basically, it's going to go quite fast. We are just selecting 6 locations. We click deploy. It's going to build the Golang app from the GitHub repository and deploy it across the 6 locations. And it takes approximately 4 minutes to deploy in 6 locations right now. So this is quite fast. We're trying to make it even faster. What you have on top left is actually a public URL, which is provisioned. So you have your TLS traffic, which is going to be completely, you have actually a TLS certificate, sorry, which is going to be provisioned for you. You don't have to do anything. You have a domain, which is provisioned. And you also have a private network, which you'd see on the right of the screen, which is provisioned automatically. So you can actually try it out on this address. So if you go to infobip-yan.koyeb.app, you'll be able to hit one of the app I deployed this morning, and you'll see the latency you have toward our edge network and toward the core location. So this was done this morning. So the edge location we get here from Zadar is Vienna, and the core location is Frankfurt. And you might actually have funny results depending on your provider, because part of the traffic routing is controlled by the ISP, and it's not about a question about what is the shortest path. It's more a question about what is the cheapest path, which is not necessarily the shortest path. But this is another subject about purely connectivity and how the peering agreement work. But basically here, we, on our wireless network, I had like 40 milliseconds to the edge network and 80 milliseconds to the application. And this is what's happening when you hit such an app. When you type infobip.yan.koyeb.app, we are going to resolve the domain name to an unencasted IP, which is actually announced by several locations. So depending on where you are in the world, you'll get the same IP. But you will not hit the same edge location. So if you use the exact same URL from New York or using a VPN, you're going to land in the edge location in New York. And basically, this layer provides acceleration. So it's going to terminate the TLS connection. It's going to also provide an HTTP3 layer, which is multiplexing connection and is faster. And it's also going to provide content caching. The next step is then to reach our core locations where your container is actually running. So, it's actually going to route the traffic to the nearest core location, which is going to figure out if there is actually a container running or not. And then it's going to serve the request. And that's it for me today. So I'm happy to take any questions there might be. So if you want to try it out, it's available on app.koyeb.com. We're happy to give $100 of credit to get you started. And you can follow us on Twitter or anywhere. If you scan the QR code, it's just sending to our blog, which is actually covering how we build the platform. So yeah, that's it.